The title, I would say the title of the song, the title of the talk is The Impact of Social Rank on Saliva Cortisol, Testosterone in relation to pro-social behavior in humans. Before I start with that, how to go forward? That's it. Thank you. I just want to mention my first attendance on, thank you. My first attendance on the conference was 2008. It's 10 years from today. And I had made a session, I had a talk in a session where I could introduce a theoretical approach of the game theoretic play behavior in humans. And as you know, theoretic game theory has something to do with mathematics, with sociology, and with pro-social behavior. And pro-social behavior, all these guys made so much impact and were able to bring the functional aspect nearer to all people. And I had this talk at the first time where I thought this is a very important impression, or a very important point, to evolutionary point, to the evolution of cooperation, pro-social behavior in humans. And what all, or the most of the studies are missed, was the including of the social rank in humans. Social rank was a parallel evolution to this type of behavior, and this made it, for me, clear to include the aspects of the social rank. And at this conference, we are very happy because I was awarded with the Best Paper Award, and this was a major motivation to go on with the topic. Let me give a short introduction here. During these decades, I already mentioned this. The important thing is that hierarchies and pro-social behavior are you find it in every society, in every human society. And all these characteristics of pro-social behavior, like cooperation, altruism, direct, indirect, reciprocity, and punishment of free riders, we can see that everywhere. Even we can see it in all social living vertebrates. So they act genetically and behaviorally all the same. To our specific evolutionary traits, cooperation is in the field, or in the order of primates, very well developed in an evolutionary traits. And normally people, social living people, sociologists and so on, they are talking about cooperation. Cooperation means to assist or support others. But in an evolutionary context, cooperation has something to do, consequences with the genetic fitness of the individuals who interact. And this is belonging to resources. We always talking about resources. We don't, as biologists, we don't believe in behaving good, behaving bad. The consequences of if I will cooperate and the person who rejects to cooperate with me gives me, who does not receive a cooperation, troubles, physiological troubles and troubles in resource availability. So this is the, and in more important terms, in genetical fitness as well. So cooperation studies has to include all these social aspects society is belonging to. All humans and all primates live under hierarchical structures. So there is a little bit difference in the definition, but we should not be talking too much about that. The interesting thing is that humans live in parallel societies. What does it mean? You can have a very low socioeconomic status in your job, that you earn less money, that you have no good education system, and the job per se is not a very good job. But on the parallel side, you can be the president of a bowling club. So in this bowling club, you be the Mr. President, and in your job, you're a inferior person. So it is much more complicated than in non-human primates. The point about these social styles we have which are associated with hierarchies. So there we have the same social structures like non-human primates, and we have, for example, egalitarian systems or the social styles, and we have despotic systems. And the big difference where evolutionary egalitarian system can establish is about the resource availability. And the resources are for egalitarian systems. You find it in indigenous peoples nowadays, that they all live in the rainforest and they have an equal distributed resources. And in our system, in our Western system, for example, the resources are not equal distributed, they are skewed distributed. And it is the point of the democracy that this is a despotic system where few people have a lot of resources and some people have less resources. What I'm coming back to these cooperation prosocial aspects here, what I answered or what I said before, this occupational, this working process is very interesting because nobody really investigated the physiological impact on cooperating or non-cooperating in the receivers. And this is, would be an interesting thing. So here is mentioned cortisol, and cortisol is the typical stress hormone released from the adrenal cortex. And this is related to a lot of diseases, inflammation, immunological, and of course of cardiovascular diseases. And this is the point where we have something real applied in this research direction. I just want to mention one thing, for example, the costs for the society for cardiovascular diseases in relationship to working conditions. So the EU, the European Union, has to pay $196 billion per year because of the cardiovascular risk and cardiovascular costs. So this is a big, big issue. We have to deal with all that money. So it's coming back to that, what I mentioned before Najib was not here, that I'm very thankful. He always gave me the opportunity to come here since 10 years frequently, and I was always able to present my newest results at the conference. So there's a big, big support from his side, and I thank you so much for that. And I'm talking about the effects of different socioeconomic status on fairness behavior in relation to that cortisol excretion rates. First, what we did since 2008, that we tried to look at, is there a difference if students have an instructor and the instructor has the same, is a student as well, compared to a professor. So the academic system is very good for doing some hierarchical stuff because it is a hierarchy like the army. We have a strict hierarchy. We have the full professors, we have the associated, the assistants, and more or less the people who are really inferior in the scientific stuff. And this is what we made. Instructions from a student, similar rank like the student, and from a professor, full professor. I don't want to go into detail of the experiment, but I thought people are more stressed, students are more stressed if a professor gives them the instructions. And what you see here is it was exactly the opposite. They were less stressed, they reduced the cortisol titers during such a session, and they were very stressed, significantly stressed, if they had a same ranked instructor. So this was a very surprising thing. Obviously, they love to be guided by a high-ranking individual. This is the first publication we made, or one of the publications, effect of this status on cortisol. The study investigated how different socioeconomic status and the degree of cooperation modulate cortisol. Participants were low SES, were randomly assigned to a computer-stimulated game of virtual high or low SES co-players. So this is an important thing, because in the game theory, The people always tested normal people playing against each other, whether they cooperate or they do not cooperate. We rejected that approach. We programmed virtual individuals representing a high status and we a low status, and we also programmed their behavior, whether they cooperate or whether they do not cooperate, to see what happens with people when they receive a no cooperation. What does it to their physiology? Has this an impact? We predicted some stuff, but this is not so interesting. So we have more than 100 students. We tested more than 100 students. They had to face a repeated cooperation game. This was a game consisting of 20 minutes and repeated 8 rounds. So they had to play with a high-ranking SAS co-player or low-ranking SAS co-player 8 times, 8 rounds. The study design was programmed by using a Z3 experimental software. This is from the game theory in Zurich written, and we adapted it for our needs. So we had a 20-minute game period, followed of 2 20-minute relaxation periods. Relaxation periods we took, and you can introduce it later, this is, we wanted to follow the cortisol during a certain time amount. The typical virtual co-player of a high SS was 35 years, held a master degree, supervised more than 5 people in his job, and has a monthly net income of 3,000 euro. So this information was, if a student has to play against a high SES co-player, has to know what kind of person is it. They did not know that this is a virtual player. They thought they really play in reality against such a person. And the typical low player, low AS co-player, was 25 years old, had a bachelor degree, and earns 750 euros. And this matched pretty good with the students, so they had a similar rank. Virtual players were so programmed to choose always the unfair option in response to an unfair option of the participants. And we had 2 kinds of reciprocations for low virtual SES players and high virtual SES player. The fair choice was they responded in cooperation in 45%. And the unfair version was whether what they did, the participants, they only reacted in 20%, so that we had a real clear answer how the cooperation of the co-player is. The game was always started from the students, by the students. Then we have a payoff matrix, and with that setting, we have a low SES virtual player representing low fairness, a low SES representing high fairness, a high with low fairness, high SES with high fairness. And according to this pairing, we took these salivary samples. We had 3 morning samples, resting samples. We had, after the test, 1 sample, and then for the relaxation periods, two samples. This was done kind of testing what happens, the influence of the game to the physiology, to the cortisol reaction. And it was, they had to play, the test group had to play the game, but without the framing of high, low, high fairness, high, low SES, high, low fairness. And just playing and the control group just looked landscape pictures. And the test group had an increase after the test of cortisol, so this was the impact of the test. And during the relaxation period, both groups were equal, and they decreased in their cortisol secretion rate. These are from the test, from the real testing, the results. And just concentrate on this, on the left part and on the right part. There's the biggest difference. If the students played against low SES and low reciprocity co-players, virtual co-players, they had an increase of, but not an insignificant increase in cortisol, and a decrease, not significant decrease in time in the relaxation period. And if they play against a high SES, high socioeconomic status, and high reciprocity agent, virtual agent, then they had an increase, a significant increase of cortisol after the test, and a significant decrease in cortisol in the relaxation period. So interesting, if there was any high, for example, low SES and a high reciprocity, you have a better decrease in the cortisol levels, and if they play against high socioeconomic agents, they have a same reactivity compared to the former one. So the setting of how the cortisol reaction is manipulated is very important and has a relatively tremendous impact in this cortisol reaction rate. And this was the post-game recovery rate, and the post-game recovery rate revealed in a general linear mixed model that it was the effect size was greatest in the socioeconomic status of the virtual co-player. They had to do it, students had to do it twice. This was the first time, and then the second time, first time, second time, first time. And then you see the motivation, how to act. If they play against the first group, LES, low reciprocity, the second time they won't cooperate anymore. If they play against a high reciproc individual, they are motivated to cooperate the second time, so they learn. And if they do play against a high SES but low reciprocating co-virtual player, they are not any more motivated. So not reciprocating means they are not motivated in following times. The most motivation they had to cooperate was the last. Playing against a high socioeconomic status and a high reciprocating individual is the greatest motivation for them. So possibly, and this is the conclusion of the first thing, possibly these people, it is not a really stress reaction we measured with cortisol. Possibly we measured arousal, that they are more focused and interested to play against these people with a high status and high reciprocity rate. But very interesting is we found distinctive saliva cortisol responses under different socioeconomic environmental game conditions, and they have all an impact to the physiology of the individuals. The second thing was a real life experiment. We made a contract with the Austrian armed forces, so we could, in the military, it is similar organizations like a university from the ranks. And this was a very interesting thing, and we were allowed to test soldiers in this placings. So the study investigated the impact of military rank on fairness and behavior in relation to salivary and testosterone in males. We were able to test 180 members. Again, a similar game they had to play like before, computer-based guard duty. What is guard duty? Everybody in the military has to spend a tremendous amount of standing guard. For example, there is a bar at the camp. They tell you you can go in, you can out. So this is a boring thing, and nobody is really excited to do it. And we programmed our computer program that they can play a guard duty game. The rank groups were warrant officers, this was our high group, and enlisted men who had to make their duty as a statesman to be in the military. They were, you see on the red thing, they were fairly similar in their sociology. They had the same amount of education and so on. Not a big difference. The biggest difference was the rank difference between the both. And the experiment was in that way that one participant we had 2 rooms. One room was with a computer and there was the standing guard, and in the other room was a computer where is the resting guard. And the standing guard had, the computers were connected, and the standing guard had to send a message how long he will stand and do his guard duty. And if the resting participant, accept that offer, then this standing guard has to stand, for example, for 5 minutes. Then a countdown came and counted down until this standing was over. Then the standing guard made the office the question, will you relieve me? And if the resting soldier said yes, then he has also sent a proposal, 5 minutes, and you can, I will relieve you 5 minutes. If he doesn't do it, if they have no consent in that, then the standing guard has always stand the whole procedure, and the whole test was for 40 minutes. And this was the interesting thing. Randomly, high ranking or low ranking were first standing and then resting, but the resting person had to make the decision how long the standing guard has to stand. This was the interesting impact here, or design here in that test study. And he had the control of the resting one, had the control of the whole experiment, of the standing time of the standing guard. And it lasted 40 minutes, the whole procedure lasted 40 minutes, and we had 3 consecutive relaxation periods to check the course of cortisol. And of course, both guys met before the test started, and everybody was aware against whom he's playing, not personally, but from his rank, military rank. So they knew each other. This is the high ranking and I'm the low ranking, for example. And the interesting thing is, if the low ranking, the enlisted guard were the standing people, then the high ranking people, or high ranking soldiers, were much more unfair than the low rankings. The low rankings were the fair players, and the high ranking were the unfair players. Fair options was extremely below the fair option of the low rankings, and hyperfair was that more than 20 minutes, for example, fair was each had to stay play the standing guard 20 minutes, and hyperfair is if one is, has to stay more than 20 minutes. So the high-ranking military tried to play the game unfair, significant unfair. Before the experiment, we always had also had the salivary measurement, and the testosterone, the resting levels, the testosterone levels at the beginning of the experiment, before it started, was significant, not marginally significant higher than of the low rankings. And T was, this is the concentrations of T, and the C levels was also marginally significant between the ranks. So high-ranking soldier from the beginning had a higher cortisol level and a higher testosterone level. Age was not correlated with the hormonal stuff. You see that here, these are the gray bars are the high rankings, and the yellow one the low rankings. This is the cortisol concentrations during the test phase. Here, after 40 minutes, the game ended, and then was the relaxation period. And we had, for the high ranks, the highest, the cortisol was increased during the whole procedure. And it was using a linear mixed model. It was correlated positively to the resting period. So the high ranking, completely different to the former study, we are not able to go down with their cortisol in the resting period, in the relaxation period. They had a stable high ranking, which was correlated with the testing period. And the low ranking, there was no real connection to cortisol expression phase, and they were fairly stable during the whole experimental procedure. So these are the asterisks are the mean, the median, and the quartiles. Testosterone, the same picture. They had elevated testosterone levels during the whole period, but there was no significant correlation or regression to the testing period. But anyway, they had at the beginning much more higher testosterone level compared to the end. So they got a little bit down, but it was not really correlated, but they got a little bit down in their testosterone. So you might say they were possibly psychological castrated during that kind of test. So this was the major finding, and I'm very happy about, because I'm working with non-human primates, for example, with Japanese macaques, and these hormone titers are exactly the same like you will find in a despotic non-human primate system. The males have high cortisol and high testosterone levels, which might include some physical problems, because testosterone and cortisol is a very negative impact to immunological functions. You have the cardiovascular system and so on. So this is in that experiment the interesting thing. To summarize that, it was more or less soldiers played more unfair, and they had problems, I think so, this is our association, they had problems to play fair to inferior people, to low-ranking people in such a system, such a despotic system. This is a summarize the whole studies, but what I want to say is we are not really aware whether these cortisol expression rates do really mean that the people are stressed. We know if the cortisol in learning curves and so on, if cortisol is a little bit increased, the people or animals are more focused to a problem and will solve this problem. If people are not focused and have not this cortisol titer, they have a bad performance. So possibly this has not something to do with stress reactivity, with be focused on a problem. This could be the point. The same is for testosterone, but the testosterone is a completely different story. I think it has something to do with status. They are aware that they have a certain kind of status. And according to the to our occupational stress hypothesis or ideas to the working process, I think if in real life happens something like this I showed you to play it in the first and second study, it may be not a problem if we have a single interaction or two interactions in a week, but it is the most problem in rejecting fairness or rejecting cooperation is if these behaviors are repeated in a long-term run. Then people could be increased in their cortisol reactivity, and then we are going to a system where the adrenal cortex doesn't work anymore in a proper way. Thank you very much.